Husaberg went a different way, by tilting the cylinder 70 degrees forward. In motocross, engineers are fighting the same war: mass centralization versus packaging. You want the heavy stuff low, tight, and centered between the axles. The problem is a four-stroke single-cylinder engine is tall. The cylinder stands up, the head sits high, and that mass lives above the frame rails where it hurts your handling every time you hit a rut or a G-out. Husaberg looked at that problem and made a decision nobody else in the industry had the nerve to commit to. They tilted the cylinder 70 degrees forward. Not the usual 10 or 15 degrees that Honda, KTM, and Yamaha use to slightly optimize airbox space. 70 degrees. That's 20 degrees off horizontal. The engine is almost lying on its face inside the frame and everything downstream of that decision. The frame, the airbox, the oiling system, the exhaust had to be completely rethought from scratch. Why tilt the cylinder at all? Start with the basics. On a conventional four-stroke motocross or enduro engine, the cylinder is close to vertical, maybe tilted forward slightly. The crank is the heaviest rotating assembly in the engine. Flywheel, crankshaft, connecting rod, and it sits at the bottom of the engine, well below the cylinder and head. The cylinder and head above it are lighter but tall, and they push the engine's mass upward and forward of where you actually want it. The real problem isn't just weight height, it's gyroscopic torque. A spinning crankshaft acts like a gyroscope. The further that spinning mass sits from the bike's overall center of gravity, the more leverage it has to resist direction changes, fight chassis flex, and load up the frame during acceleration and braking. Every time you try to lean the bike, flick it through a rut, or muscle it over a root, that gyroscopic effect is working against you. The further the crank is from the bike's center of gravity, the worse it gets. What Husaberg actually did to the crank. This is the part the design is really about, and it's counterintuitive. When Husaberg tilted the cylinder 70 degrees forward, the crank didn't stay in the same place. It moved significantly, more than 100 millimeters higher in the chassis and approximately 160 millimeters further rearward. That repositioned the crank's rotating mass much closer to the bike's overall center of gravity, the point roughly between the axles, low and central, where the bike naturally pivots. With the crank sitting closer to that point, its gyroscopic forces have far less leverage on the chassis. The torque effect that a spinning crank normally imposes on the frame during direction changes is dramatically reduced. The bike feels lighter to flick, easier to pivot, and more neutral in the air. That's the engineering payoff. Everything else, the airbox, the exhaust routing, the frame design, is a downstream consequence of chasing that one benefit. What 70 degrees actually looks like. Visualize this: a stock KTM or Honda 4-stroke cylinder tilted maybe 15 degrees forward from vertical. Now keep rotating that engine forward another 55 degrees. The cylinder head is now pointed almost straight at the front wheel. The intake port, which would normally face rearward and slightly upward on a conventional engine, now faces nearly straight up toward the sky. The exhaust port, which would normally exit forward and slightly down, is now pointing almost straight at the ground under the engine. The spark plug, instead of being accessible from the top of the bike with a socket extension, is buried under the front of the engine near the radiator. The Airbox solution, and why it matters. Here's a significant packaging payoff. On a conventional bike, the airbox has to live somewhere behind and above the engine, competing for space with the subframe, the fuel tank, the seat, and the shock. That forces airbox designers to compromise. Smaller volume, tighter filter, more restrictive path to the throttle body. When Husaberg tilted the cylinder 70 degrees forward, the space directly above the engine opened up. They used it. The intake port now faced upward, so the throttle body sat directly on top of it. Short, direct runner, no bends. The airbox fed clean air straight down into the injection system from a central, protected position. From a breathing standpoint, it was genuinely efficient, and the filter stayed cleaner longer in dusty conditions because it wasn't sitting directly in the rear wheel's roost path. EFI from day one. The 70-degree engine launched in 2009, and it launched with electronic fuel injection. This is worth stating clearly because the upward-facing intake port raises an obvious question. What about fueling? A carburetor mounted flat on its back has real problems. The float bowl orientation changes the effective fuel level, and fueling behavior shifts as terrain angle changes. Husaberg skipped that problem entirely. The 2009 generation paired the radical cylinder angle with a modern EFI system from the start. Short intake runner, centrally mounted throttle body, engine management handling fueling precisely regardless of orientation. The tilt and EFI were designed together, not sequentially. The oiling problem and how they solved it. Lay a 4-stroke engine nearly on its side and conventional lubrication becomes a problem. Oil pools against the wrong surfaces, pickup tubes can run dry under hard acceleration, and surfaces that need splash lubrication aren't getting it at the right angle. You can't just tilt the engine and rely on gravity to sort it out. Husaberg ran a pressurized pump system with a dedicated scavenge pump. A positive displacement pump supplied oil under pressure to the crankshaft, pistons, and valve train. A separate suction pump scavenged excess oil out of the cylinder head and returned it to the transmission casing, which doubled as the oil reservoir. Oil delivery was active and pressure-driven, so the angle of the cylinder became irrelevant to lubrication reliability. The system added complexity, but it worked. The 2009 generation engines didn't have the lubrication reliability issues that had haunted early Husabergs in the late 80s and early 90s, which ran without an oil pump and depended on the timing chain for oil delivery. Frame geometry enabled by the tilt. Because the cylinder head was no longer occupying the upper front zone of the engine bay, Husaberg's engineers could design the frame differently. The main frame spars could be lower and tighter. The steering head position, and therefore rake, trail, and front-end geometry, could be optimized for handling rather than forced upward to clear a tall engine. Fuel tank location also changed. With the 70-degree layout, a conventional single tank over the engine wasn't possible. Husaberg used a split tank system, a primary tank forward with the filler cap up front and a secondary tank molded into the plastic rear subframe under the seat. This distributed fuel mass more neutrally front to rear, and as fuel burned off over a long enduro stage, the weight loss was more balanced than on a conventional bike where the tank empties from high up over the engine. With the exhaust port pointing nearly straight down at the front of the engine, the header pipe routing looks unconventional. Rather than sweeping down from a forward-facing port and going under the engine or around the side in the conventional way, the Husaberg header exits from under the engine, sweeps rearward and outward, then makes its way to the silencer tucked tight along the right side of the bike. It looks almost backwards at first glance, but it clears the front wheel cleanly, delivers good ground clearance, and opens up right-side packaging space that a conventional pipe would occupy. Heat management near the rider's boot was a real concern. The header lives low and close to where your right foot works. Burns from Husaberg pipes were a known hazard, and heat shields were functional, not decorative. How it actually rode. Riders who put time on Husabergs consistently reported the same thing. The bike felt compact. Not small, compact. The mass felt centered directly beneath you rather than distributed in a tall, long package. In tight enduro conditions, slow technical riding, off-camber sections, pivoting around roots and rocks, that centralized mass translated directly into a more maneuverable machine. You could rotate the chassis more easily because the gyroscopic resistance that normally fights you was reduced. Less leverage working against you when you tried to flick it. At speed, the benefit showed up through rough braking bumps and choppy high-speed sections. The bike tracked more predictably under hard braking, because weight transfer was less dramatic with the rotating mass sitting closer to center. The rear stayed more settled, the front loaded more progressively. The trade-off was a learning curve on ergonomics. The geometry the tilted engine enabled was specific, and the narrow central airbox between the knees felt different from conventional bikes. Riders switching from a standard KTM or Yamaha needed a few sessions to reset their body position instincts, particularly knee grip and weight-shifting cues in corners. KTM's acquisition and what happened to the concept. KTM purchased Husaberg in 1995. For years, the two brands coexisted, with Husaberg functioning as something between a development platform and a premium niche offering. KTM didn't adopt the 70-degree tilt for their mainstream line. Their engines use a conventional forward tilt in the 20-degree range, but the acquisition gave KTM access to Husaberg's engineering and manufacturing thinking during a critical period of their own engine development. Husaberg even adopted KTM's ready-to-race slogan before KTM took it back as their own. By the early 2000s, KTM had refined their four-stroke platform to the point where the Husaberg's mass centralization advantage was no longer the differentiator it had been. KTM's chassis and engine packaging had become genuinely competitive on those same metrics through conventional means: tighter engine cases, repositioned components, optimized frame geometry. The brand ran through 2014, its 25th anniversary year, before being discontinued and fully absorbed into KTM. The tilted cylinder died with it. Why nobody else fully committed to it? The concept worked. Husaberg built competitive, well-regarded enduro bikes for years using this layout, but the downstream engineering cost was high. The oiling system, the exhaust routing, the split fuel tank, the plastic subframe, the frame design, every one of those was a harder problem on the Husaberg than on a conventional layout. Kawasaki explored a similar 70-degree concept through patent filings, but never put it into production. For a large manufacturer with a proven conventional platform, the investment required to switch layouts only makes sense if the performance advantage is unclosable by conventional means. As chassis design, suspension technology, and engine packaging improved across the industry through the 2000s, that gap closed. The radical approach became harder to justify when conventional approaches kept getting better. The Husaberg remains the only production dirt bike to fully commit to a 70-degree cylinder layout. It's a case study in engineering conviction, A company that identified a real problem, chose the most aggressive solution on the table, and built an entire machine around it rather than compromising back toward the norm. Husaberg bet everything on one engineering decision and built a machine nobody else had the nerve to copy. Triumph took a completely different approach. They didn't try to out-engineer the Japanese or the Austrians, they out-strategized them. How a 70-year-old British brand walked into modern motocross and immediately became a threat is a story worth understanding. That's the next video.